As we saw with the videos where we were zooming in for local linearity, we know that a tangent line is very, very close to the actual curve if you just zoom in enough, okay? So one big thing in calculus is to come up with the equation of the tangent line, because an equation of a line is a lot easier to use than the equation of something that might involve trig or exponential logarithmic functions. We can get some pretty nasty looking functions, but if we can get the equation of the line tangent to that function at a particular point, then we can use that equation of the line and we can get our answers much quicker, even though they're only approximations. So that's what's going on with example number 6 right here. All right, so we're going to write the equation of the line tangent to f of x equals x squared minus x to the 5th plus 3 at the point when x is 1 and y is 3. Okay, so we want to write the equation of a line. So what form of the equation of a line should we use? Well, the common form that everybody thinks of right away is slope-intercept form. Perhaps that's what you thought of as I mentioned writing the equation of a line. Y equals mx plus b. That's a good one. However, there's a better one, and that's point-slope form, because slope-intercept form requires us to know what the y-intercept is. Point-slope form, all we need is any point at all on the graph. Well, we have that. We have the point 1, 3. So again, that's not on the y-axis, but it doesn't matter because point-slope form doesn't require the y-intercept. All right, so now the next question is, do you remember what point-slope form happens to be? If not, well, it's always good to look it up, but point-slope form is y minus y1 equals m times x minus x1. Okay, that's our point-slope form. And if we think about it, well, we already have the point. We already have our x1 and our y1. x1 is 1, y1 is 3. So we can plug those in. So we have y minus 3 equals our slope, and then we have x minus 1. The only variable that's remaining, the only thing that we have to figure out is what's the slope. What's the slope of the tangent to the curve at a point? Well, our video involving the derivative song tells us the derivative is the slope of the tangent to the curve at a point. So ultimately, this is a derivative question. We need to get our derivative. Once we get our derivative, we can plug in our point, and then we have the slope of our line. So let's do that. Let's get f prime of x. So over here, we have f prime of x. We're going to derive x squared minus x to the 5th plus 3. Well, you're old pros at this now. X squared derives to 2x, and x to the 5th derives to 5x to the 4th. And 3 is a constant, so it derives to 0. So f prime is 2x minus 5x to the 4th. We're interested in the point when x is 1 and y is 3. Well, that means we're plugging in 1 for x. So we need f prime of 1. That's what our slope is going to be. Okay, so that means we plug in 1, so we have 2 times 1 minus 5 times 1 to the 4th. Still 1. 1 to any power is 1. So we have 2 minus 5, which is negative 3. There's our slope. So we can now go back here, and we can replace our slope with negative 3. So our task was to write the equation of the line tangent to this curve, and that's what we've done. Here's our equation right there. Okay. Now the question is, well, do we have to write this in slope-intercept form? No. You were just asked to write the equation of a line. This is the equation of the line. It's got a y, it's got the x, we're good to go. So part A is done. Part B says, hey, let's use this now. Use this equation to approximate f of 1.1. So let's plug in 1.1 for x, so we can get an approximate value of our function. If we plug 1.1 in for x, we have y minus 3 equals negative 3 times 1.1 minus 1. Okay, 1.1 minus 1, 1 and a tenth minus 1 is just going to be a tenth. All right, so we have y minus 3 equals negative 3 times 0.1. 0.1 times negative 3, well, that just moves the decimal over, so we just get negative 0.3. So y minus 3 equals negative 0.3. Okay, that's what happens when we multiply those two numbers. Now we got to get y out by itself, so we add 3 to both sides. So y is equal to negative 0.3 plus 3, which means we're going to get 2.7. That's our approximation. The function should approximately be equal to 2.7. Let's see what it's actually equal to. I need you to take out your calculator right now. You can pause the video and plug 1.1 into the function. What do you get? Well, if you punched in, you've got 2.599. Call it 2.6. So the actual value is 2.6. We were able to get 2.7 using the tangent line to approximate that, right? And which was easier to do by hand. Again, we used our calculator, but if I asked you to do both these by hand, would you rather plug 1.1 into here and be off by 1/10, or plug 1.1 in here, which takes more time and a greater degree of difficulty? So we can use this equation of the tangent line to approximate values. And that's one thing that we like to do in calculus. Take these very complex functions and then get a simplified version of them and use that simplified version to approximate what's going on. You're going to see that as a theme throughout the course of the year.